So the question was that you're starting from point A, okay, then you go to B, then C, and then finally to D. Okay, so over here, this is 0 meter per second. Over here, this is 30 meter per second. It is going with an acceleration of x meter per second square. Okay, then over here, it is going with a constant speed for t seconds. So it is maintaining that speed of 30 meter per second, and then finally it slows down with negative 3x meter per second square and comes down to rest. That is 0 meter per second. Correct?
Yeah.
Now, if the entire distance covered, if this entire distance covered is let's say this is 6,000 meters given, right? 6,000 meters, that is 6 kilometers basically. Okay, and 5 minutes, which is 300 seconds. So you're given this much data, then you have to find out what is x and what is t, right? This is what you have to find out. So this was the question. This was the checkpoint. So let's understand how to do this question. So see, the thing is, the best way to basically draw the graph. Okay, so what I'll do, I'll draw the graph for this. So you starting with the 0, okay, the speed time graph basically. You're starting with the 0 meter per second. You go with some speed, like you reach some speed like 30 meter per second ultimately. Then you maintain this constant speed, and then after that, like you slow down until you come down to 0 meter per second. This is the thing. All right. Now the total time taken from here to here, this is 300 seconds. Okay, and this time taken, this time is t seconds. Okay, the total area gives you the total distance covered. This area is basically the total distance covered, that is 6,000. You're getting it? But what is the area of trapezium? What is the area of trapezium? Half into sum of parallel sides into height, isn't it? What are the parallel sides over here? 1
t and 300.
Perfect. So t plus 300 into the height. What is the height over here?
30 meters per second.
Very good. So with that, we get t plus 300 is equals to 6,000 into 2 divided by 30. Okay, you're getting it, right? So what do we get in that case? This is equals to 400. So we get t is equals to 100 seconds. So we got t. Easy, isn't it?
Right. So the 6,030 cancel. Okay. So it takes that section, it's 100 seconds.
So we got t is equals to 100 seconds. You understood that,
and then
right?
We need to find the gradient of the x.
Perfect.
Of the first section.
Yes. The first section, the gradient is what is the gradient? All right, so let's divide it in these 3 sections. So in the first section, that is from A to B, then second is B to C, third one is C to D. Okay. All right. So now over here, you have U is equals to 0, V is equals to 30, T is equals to, we don't know, let's say T1, and then A is equals to X. Okay. For this one, it is a constant speed. We already know that T2 is equals to 100. Okay, T2 is equals to T, which is 100. And then for this one, U is equals to 30, V is equals to 0, A is equals to minus 3x, and the time taken, let's say that to be T3. Okay, you agree? Now,
yes, I agree.
So what do you think, what formula can be used for this first part and the third part? So,
so
you have UV,
the first one. We have UV, A, and we have So there's we need to find A and we
Yes.
need to exclude T.
See, the thing
So we
is,
need a formula that excludes T.
we can write T is equals to V minus U over A. Okay, so you'll be getting the value of some expression of T in terms of X. Okay,
Okay, yeah,
because we know the total time, and we
right,
know this that this part is 100 also. Okay, so what we
right,
can
right.
write, that T1 is equals to 30 over X. Okay,
Okay, yeah,
T2 is equals to 100, and T3 the same way. Same way we can write T3, that is 0 minus 30 V minus U over A, that is minus 3X. So T3 is equals to
and it
minus,
cancels
yes, so 10 over X.
10 over X, yeah.
Now, the total
You
time
can put it
taken,
into a formula and you can equate it to 300. So 100 plus 30 over X plus 10 over X is equal to 300.
yeah. So then this is 40 over X is equals to 200. So X is equals to 40 over 200, that is 0.2 meter per second square. We got it, right?
Yeah, I see.
So was it like very difficult?
No, it's just the approach with the graph. I didn't think of that actually.
No problem. Okay, so now I have given you, in fact, like all types of questions that can come from the first chapter. I mean, like, sorry, not the first chapter, kinematics part, the motion in one dimension. Okay, yeah. Now
Yeah,
let's go ahead. So now the next part that we are doing will be covering the entire mechanics in 2 more lessons. It will take. Okay, mechanics is
okay,
the biggest one. So in 2 more lessons, we'll be able to cover the entire mechanics. Then,
okay, great.
yeah, thermal physics can be done in one session entirely. Along with the thermal physics, we'll finish the energy production also. Okay, in one
Okay,
session itself. Oscillation waves is another big hurdle that will take like another 3 lessons. Electricity will
yeah,
take 2 lessons. Okay, so likewise, in definitely in 15 hours, we'll be able to cover everything. Now you have to like pace up with it. Okay, you have to use the recordings, learn it like at home. Okay,
yeah,
before the
yeah,
next class every time. Yeah, all right.
yeah.
Chalo. So let's go ahead. So let's start with the next thing, that is the projectile motion. So the projectile motion is a very easy type of motion, trust me. Okay, so the thing is, in the projectile motion, so it is basically the two-dimensional motion.
Okay,
So this is the two-dimensional motion. Okay, like suppose if I'm considering this object launched at a specific angle. Okay, so this is
okay,
launched at a specific angle, at angle with some speed, initial speed. So what happens that this objects cover certain height. Okay, it covers certain height as well as it covers certain
okay,
horizontal distance. So this is x.
okay,
Okay, so this kind of motion where it is having the constant, where it is having like some vertical distance as well as some horizontal distance simultaneously. Okay, such
yeah,
motion is the two-dimensional motion. It is having motion in 2 dimensions. It is known as the projectile motion. Okay, this is the parabolic motion. I'll tell you why it is also known as parabolic motion. Okay, because of some equation. We'll see that. Okay, all right. So now, what is the projectile motion or this two-dimensional motion? Why do we call it two-dimensional motion? See, the thing is, this u, we can actually get the components of this u in both the directions. Like if you learn vectors, so the
yeah,
vectors, if a vector is at some angle theta, so it is having its effect in both the directions. It is having its effect in both the axes. In this direction, it
yeah,
is r cos theta. In this axis, it is r sin theta. Exact same way,
yeah, yeah,
we can get the components of u. The components of u in this direction, this is u cos theta, and this component in vertical direction, this is u sin theta. Okay, you understand like
yeah,
how to get the components of a vector, right?
yeah, yeah.
So now the speed, which is at a specific, at some angle, it is having its effect in both the directions. Okay, horizontal and vertical.
Yeah.
So you have this two-dimensional motion. Why do we call it two-dimensional motion? Because it is two times one-dimensional motion. Okay, so there are two one-dimensional motion which are taking place. What are those two one-dimensional motion? Yeah, one is the horizontal motion, and another one is the vertical motion. Okay.
Yeah.
Vertical motion. All right. So the horizontal motion. Now we need to avoid air resistance always. Avoid air resistance.
Yeah. We have to they don't count that as well.
Yeah, exactly. So avoid air resistance. So if you avoid the air resistance, then this horizontal motion, is there any force in the horizontal direction? Is there any force acting in the horizontal direction?
The initial speed.
No, that's not the force, that's the speed. Yeah. So there is no force acting in the horizontal direction, right? So no force. In the horizontal motion, there is no force. That means there is no acceleration, isn't it? That means it is having the not. So that means it is having the constant horizontal speed. Constant horizontal speed. That is u cos theta, as seen in the above diagram. You understand that, right? Okay.
Yeah.
So it is. Yeah. So. So if you go with the speed versus time graph, so horizontally it is this constant.
Completely flat, yeah.
U cos theta with respect to time. You're getting it? Whereas, the formula over here that we use for this is just the distance equals to speed into time. That's the only formula that we can use actually. Okay. Now the horizontal distance that is covered, that is also known as range. Okay. How long it will be covering, how long it will be going. So that is basically the range. So that is equals to speed into time, the horizontal speed into time. You're getting? So R is equals to U cos theta into whatever time that it takes. So it's the only formula.
Yeah.
In this particular case that we can actually use. Right. Now, when we consider the vertical motion, so vertical motion, is there any force acting in the vertical direction?
Yeah, there's a gravity.
Definitely. So the force which is acting is the gravity. Okay. And because of that, the acceleration which will be playing role over here is acceleration due to gravity, which is G over here. Yeah. Now, you should understand that it is always acting in the downward direction. We learned that thing while doing the motion under gravity. So A is equals to negative G, right? If you follow the sign convention, we know that A is equals to negative G. It is always negative, okay? Because it is always acting in the downward direction only. Okay, so anything, any vector which is acting in the downward direction is considered to be negative. Okay, all right. So if you talk about the speed versus time graph, okay. So for this, the speed versus time graph, it will be having some high speed. It reaches 0, and then it further continues like this. You're getting it? So this is the
because it
this is the highest point.
Yeah, because it loses all the initial and speed and then accelerates because of gravity.
Perfect. So the formula that we can use for this thing is those kinematical equation which we learned earlier, and V is equals to U plus AT with the sign convention, with the proper sign convention. Then S is equals to UT plus half AT square, and V square equals to U square plus 2AS. All these things should be used with the sign convention. Sign conventions. Okay. And
that means you just include the sign, right? You just put the
use vectors only. Yes. So you need to use it with the sign convention. You're getting right. So So see, the thing is, so we have this kind of vertical, horizontal, and the vertical motion. When you combine them, you get the projectile motion. Okay. So basically, what do we actually observe overall? That if this is the projectile, this was the horizontal speed at some angle theta. So this was the speed. So this is horizontal speed, which is u cos theta. Now that remains same. Like at all the point, it remains the same. At highest point also, it remains the same.
Doesn't change.
Doesn't change. Okay. Yeah, at all the points, it is u cos theta only. Okay, here also it is u cos theta. At every point, it is u cos theta, and so on. You're getting? But if you're talking about the vertical one, so the vertical over here, this is u sine theta. Now, u sine theta gradually decreasing. Here it is decreasing. Ultimately, it becomes 0 at the highest point, and then it is increasing in the opposite direction. The magnitude is opposite direction like this. You're getting right? Yeah. So obviously, along with that, like the angle which it is making, that is also changing. Theta 1 here, we can consider this to be theta 2, and so on. Ultimately, it is basically kind of the same angle, but in the negative. You should say negative theta basically. Yeah. If it is at the same level. Okay, this is the same level basically. So this is the standard projectile that you observe. This is the standard type of projectile motion. You're getting it? Where it hits the same level. This level, ground level is same. Okay. Now, there can be multiple types of projectile motion, okay, which we will be covering here in this chapter. So basically, it can be like you are throwing the object from this particular point in the horizontal direction. Ultimately, it is going to hit the ground. Okay. So even this kind of projectile we will be learning. Okay. Remember, like all the kinematics remains the same. Okay. Even if you change the different types of projectile, if you take the different types of projectile, still the kinematics will remain the same. If it can be thrown from that particular height in the upward direction, and then it is hitting the ground like this. So
I see.
So these are the different types of projectile that you will be coming across. Okay, so I call it like half projectile. This one I call it half projectile, and the last one I call it complex projectile. Okay, complex one.
See.
Right. So in the textbook, no such classification given, but like let's consider it this way: like standard projectile, half projectile, and the complex projectile. So we'll be learning it in 3 parts. Okay. All right. So let's understand this thing further. Remember one thing: the key to get the right answers on the for the numericals in the projectile motion is to never mix these 2 types of motion. Always treat horizontal motion and vertical motion separately. Treat them separately, you will always get the right answer. Okay. If you mix them, if instead of vertical motion, if you take the overall velocity, then you will get the wrong answer. For the horizontal motion, if you are taking the overall velocity, you get the wrong answer. For horizontal motion, take only horizontal velocity. For vertical motion, take only vertical velocity. Like that. If you do it this way, you will never get wrong answer. Okay. So now let's start with the one question. I'm explaining you one type of question over here, and then I'll give you the problem. Okay. Yeah. All right. Suppose the object is launched at with the 50 meter per second.
In the overall.
Yeah, on the standard projectile motion, this is a 50 meter per second at an angle of 60 degree. Okay.
Okay.
Yeah. So what we have to find out: calculate maximum height. Maximum height, we name it capital H. Calculate the horizontal range. After that, calculate the time of flight, the total time taken to cover this journey. So that is, let's say, capital T. Horizontal range is capital R, let's say. Okay. Now I'm giving you, so this is the first one, this is the second one, this is the third one. Now suppose this is point P. This is P. Okay. And at this point it makes, let's say, 30 degree with the horizontal. This is making 30 degree. Okay.
Oh yeah. Okay. Yeah.
Yeah. So to reach P, uh, calculate the time taken, right? So this is A part, fourth A, B, uh, the height covered, means height means this. Let's say this is small h. Maximum height
Yeah.
is this height, that is capital H. Okay.
Yeah.
So height, that is small h. And then the horizontal range covered, let's say that is x. So
Yeah.
x covered. Yeah. So these are the things. And also, like, let's say we are calculating the resultant velocity. This is v.
Yeah. Right.
So all these we have to calculate. So I have included the maximum number of questions in this one example only. Okay.
Right.
Yeah. All right. So how to do these kind of question? Let's understand how to do these kind of questions. Then after that, I'll give you some other problem. Yeah. Wait a second. I need to take a call. Okay. Let's go ahead. Yeah. Yeah, Pranav, can you hear me?
Yeah.
Yeah. All right. So first of all, what we have to calculate is the maximum height. So for calculating the maximum height, first of all, what I'll do, the very first step that to be taken over here is to resolve the speed in both horizontal and vertical direction. So that is the first step.
Right. Yeah. Yeah. Yeah.
Okay. So resolve the speed, the velocity in horizontal and vertical direction. Horizontal and vertical direction. So that is the first step. Then second step, choose the type of motion. Choose the type of motion that you wanna like you are considering. Okay. And the third step is apply the formula. Apply formula. Okay. So see, the thing is, for the first step is like resolving it. So I'll be taking ux and uy. So ux is 50 cos 60 and uy is equals to 50 sine 60. So what is 50 cos 60?
50 cos 60 is okay, I think in degrees, right?
Yeah, 60 degree. Yeah.
Yeah, so I'll just put that in. I get 25.
Yeah. 50 sine 60.
And the sine is 43.3.
So 43.3 meter per second. Yeah, perfect. Very good. All right. So we got ux and uy. And then we have to choose the type of motion. So first question is maximum height. Okay. So the maximum height. So which type of motion you will consider? Horizontal or the vertical? Definitely.
Vertical.
So you will consider the vertical motion. So what we are given for the vertical motion to reach this maximum height till this point. Okay. Till this particular point, what we are given. So we are given the initial velocity, that is 43.3 meter per second. I'm considering only vertical motion.
Vertical.
Okay?
Yeah.
Yeah. So don't consider that like this u means 50. This u over here, this means 43.3 meter per second.
Yeah.
Right. What is the final speed when it reaches the maximum height?
The final speed when it reaches the maximum height. So the distance we know. Did we calculate the distance?
No.
Yet?
No.
Oh,
See, the thing is, when it reaches over here, it is having the horizontal speed, but it has no vertical speed. So
it becomes 0.
Vy is equal to 0. So V is equals to 0 over here. Now, S is equals to is height, basically. And do we know A? A we know that is negative 10. Let's consider A to be negative 10 meter per second square. Okay, it will be given. It will be given, but like I'm for the ease of the process, I'm taking negative 10. Okay.
Right.
So you have UVAS. Which formula to be used?
UVAS. Okay, so if you have UVAS, then we need one without T. So we can use V squared is equal to U squared plus 2AS.
Perfect. Yeah. So V square, that is 0 square, U square, that is 43.3 square, okay, plus 2 into minus 10 into capital H. Do you agree?
Yeah.
So with that, we'll be able to get the value of H, and that would be 43.3 square.
Which is 1874.9.
1874.9 divided by 20.
Yeah.
So what is
Divide
it?
by 20, you get 93.7.
75, I guess. Yeah.
Yeah.
Yeah. So this is the this is giving you the maximum height over here. So we got like we solved the first part of this question. Okay, easily, isn't it?
Yeah.
Next thing is the time of flight. All right.
The
so now
time.
Sorry.
The total time, right? Yeah.
Yeah, the total time taken. So the time of flight.
Yeah.
For that, I can consider the horizontal motion. I can consider the vertical motion. When we consider the horizontal motion, the formula that we have is the distance equals to speed into time. That's the only formula that we have, right?
Yeah.
Now, are you given the horizontal distance over here? No, right?
No, we're not given the horizontal distance. No.
So we cannot use the formula distance equals to speed into time. That is from the horizontal motion. So we have to consider the vertical motion. So for the vertical motion, when it comes down to the same level, okay, when it comes down to the same level. So what do you think is the vertical displacement? Vertically, how much
zero.
it is?
It comes back exactly where it started.
Yes. So vertically, it is 0. Then we know the initial velocity. What is the initial velocity?
Vertically is 43.3.
Yeah, all vertical dimensions only. Okay, so 43.3 meter per second. Then we know the acceleration, that is negative 10 meter per second square. What do we want? We want t, which is taken as capital T. Yeah?
Yeah.
All right, so which formula to be used?
We could use displacement is equal to ut in plus 1/2 at squared.
Perfect. So this is 0. U is 43.3 capital T minus 5t square, because a is minus 10 and half into minus 10, that is giving you minus 5.
Yeah, correct? And now we have a quadratic.
5t square equals to 43.3t. We can cancel this.
Yes.
So this is 43.3 divided by 5. That is equals to, what is
8.66.
8.66 seconds. So we got time also.
Right, yeah.
Now, for the horizontal motion, we have to calculate the horizontal range. So for the horizontal motion, we have only one formula. That is r is equals to horizontal speed into time. What is the horizontal speed over here?
V cosine theta into time.
So that is 25.
25 cosine 60.
Yeah. No. X is already 50 cos 60, which we already determined 25. Yeah. So the horizontal motion is 25 multiplied with the time, right?
It is 8.66. It's 216.5.
Yeah. So this is giving you the horizontal range. You're getting it, right?
Yeah.
All right. Now the next. So these are the first 3 parts of this question. Let's understand the last part. So to reach P, calculate the total time taken, height, X, and the V. All right, now this is the main hurdle. Let's understand like how to do these kind of questions. So what I'm considering over here, this is 25, right? Horizontal distance, that is 25. Okay. What do you think is the horizontal distance over here?
The horizontal distance, it doesn't change, it's constant.
It is still 25. Yeah. And then we are having some vertical distance, which is not equal to 40. This is
not the same.
43.3, but this is not equal to 43.3. No. So, yeah. So we are given the angle and we are given the horizontal component. So, yeah, we are given this thing. This is 25 and this is 30. Yeah.
Yes. Yeah.
So can you determine this component? I mean, like the main vector and its vertical component. Can you determine that?
Okay. So we could.
Yeah,
No, we could
definitely.
not.
Yes,
But
we can.
with the
25 is
you know
equals to
that
V cos 30.
yeah, basically that you rearrange the formula for the vector.
So then V will be equals to 25 over cos 30.
Yes, and cos 30 is 0.866. 25 divided by that is 28.8.
So this is
28.8 meters per second in the
and then
vertical direction.
yeah, and then we can get the wait a second. 25 over cos 30. What's that coming out to be?
Yeah, that's coming out as 28.8.
Now Vy, how will you calculate Vy? That is V sine 30.
Yeah, so 28.8 sine 30 is 14.
14.4, right?
Oh yeah, 14.4.
Meter per second. Okay, so we got the vertical velocity. So first thing, this is solved. This part is done. We already got V to be equal to 28.8. Okay, and we got the Vy also. Vy is equals to 14.4. V is equals to 28.8. Okay.
Yeah.
Now we want the time taken for that. So see, the thing is, what is the initial speed over here? Initial vertical speed over here?
The initial vertical speed was
43.3.
Oh yeah, initially 43.3. So
what is the final speed?
14.4 divided by 43. 14. Yeah, 14 is the final.
Do we know the acceleration vertically?
We do not know the acceleration now.
Minus 10. We know that. Yeah.
Oh right. Yeah, the gravity. Yeah.
Yeah, and the time taken can be calculated. So which formula to be used over here?
U, V, and we need to find T. So what are we missing? We're missing S. We want something without S. And the first formula, V is equal to U plus AT.
So with that, V is equal to U plus AT. So what should be written?
14.4 is equal to 43.3 minus 10T.
Perfect. So with that, we get T. T to be equal to 14.4
minus
43.3 divided by minus 10. Yeah?
Yeah.
So what is that coming out to be?
Minus 41.9 divided by minus 10. And we get 4.2.
So, are you sure?
Oh, I did. Okay, no, 14.4 minus 43.3. Yeah, minus 28.9 divided by minus 10, 2.9.
2.9 meter, 2.9 seconds. Okay, so we got the time taken also. We got the time taken to reach that point. Okay, now we have to calculate the height. So to reach that particular point, to reach P, for that we are given the initial velocity vertically. We have to get the height, right? So again, vertically, you are given U is equals to 43.3. You are given V is equals to 14.4. You are given T is equals to 2.9 second. You are given A is equals to -10, and you want S.
And we want to find S.
Yeah. So you can use two equations. In fact, like any two equations, second or third one, any two for S.
Yeah, because you have all of them except actually this one you just need anything with S. So you could use any of the bottom three.
Yeah, bottom
so
two.
You could do S is equal to V plus U into T divided by 2.
Yeah, so S is equal to UT. Yeah, we can do that also. U plus V into T divided by 2. Yeah, perfect. So if we can use this one also. So what do you get?
So then we get 43.3 plus 14.4. And we 57.7 times 2.9. So we get 167.33 divided by 2 is 83.665.
83.65. Yeah.
Yeah.
Okay. So this is the distance covered. Okay. The height covered basically. Now, if you want
from initial to P.
Initial to P. Okay.
Yeah.
Now we want the X also, the horizontal distance covered in that. So we got height also, that is 83 point something. Yeah. And then we have to calculate X. So X is the horizontal motion, isn't it?
Yeah.
So we will be considering the motion horizontally. So horizontally, what is the, so X will be equal to, what is the speed horizontally? That is 25. And what's the time taken we will be taking here? What's the time?
2.9.
Perfect. So what is that coming out to be?
72.5.
72.5. Yeah. So meters. You're getting right. So this is how we get the horizontal distance also. So see, the thing is, this whole question is basically having multiple parts and explaining like all those small parts of the projectile motion. So do you have any problem in any of these parts?
No, I don't have a problem with this. I understand everything. Yeah.
Perfect. Now, let me tell you one thing. If you understand this much, okay, you'll be able to understand all the types of projectile motion. Like be it any type of projectile motion, like half projectile, complex projectile, be it any, you'll be able to solve that. Okay?
Yeah.
I'm giving you one, in fact, two questions over here. All right. So I'm giving you two questions. From here, it was thrown horizontally with 20 meter per second from a height of 125 meters. Okay. Yeah. From a height of 125 meter, it was thrown horizontally with 20 meter per second. Okay. So for this, for this you have to calculate the time of flight. Time of flight. I already told you that, like, consider a is equals to -10 when I'm teaching.
Yeah.
Yeah. Time of flight you have to calculate. You have to calculate the horizontal range. Now at this particular point, when it reaches here, it will be having some horizontal speed, it will be having some vertical speed, it will be having some resultant speed, and it will be making some angle theta over here. So this horizontal speed will be the same as 20 because horizontally it is not getting affected. Yeah?
Correct. Correct. Yeah.
Yeah. So now it will be having some vertical and it will be having some resultant speed. So, so you have to find this vertical, you have to find the resultant, and you have to find this theta also. Okay. This is the second question. And here I'm giving you the last one. Okay. So from this particular height of 125 meter again, from this particular height, an object is launched with a speed of 50 meter per second at an angle of 60 degree. Okay. Ultimately, it hits the ground over here. Okay. It's the ground over here. So with some resultant speed, vertical speed, horizontal speed, okay, making some angle theta over here. This is Vy, this is V. Okay. Now for this also, what you have to do is calculate the maximum height. Second thing, the time of flight. Third thing, the horizontal range. Fourth thing, Vy, V and theta. All these. You got it, right?
Okay.
Yeah?
Yeah.
So I'll do one of them. I'm doing this first one. The second one, this second question is basically the combination of the first question what we did and this one. Okay. You see, this
Okay,
is from
I see.
this particular height, 125 meter, and then hitting the ground, right? And this one
Yeah,
is
yeah,
like
same.
from 125 meter only, but like launched upward with that same speed which we saw in the very first example, 50 meter per second and 60 degree. That's what we had taken earlier. Yeah. So, this third question, this question is basically the combination of first two. So I'm doing this second one, and I'll be leaving this third one for the homework. Okay. Yeah.
Yeah.
All right. So let's do this question. All right. So here in this. All right. So here in this half projectile. For this half projectile, what we are given, what we have to calculate is the time of flight. So see, the thing is, for the time of flight, again, you can't use the horizontal motion. Why? Why we can't use the horizontal motion? Because you're not given the horizontal distance covered again. Yeah. You can use the formula for the horizontal motion. The formula is only distance equals to speed into time. You're given the speed. You're given the speed. You're not given the time, and you're not given the horizontal distance. So in that formula, out of three, two is missing. Two of them are missing. So we cannot use that formula. So let's consider the vertical motion only again. So vertically, what is the initial velocity? Vertical motion. What is the initial vertical velocity over here?
In the second one.
Yeah, in
or
this
the first one, 20 meters per second. Oh, vertically.
Yeah.
Vertically, we have to do the. So there is, we know that the horizontal. So A cosine of.
Wait.
The angle is like 0 degrees, right?
No, don't. See, the thing is, vertically, it is launched horizontal direction, right?
Yeah.
That means there is no speed in the vertical direction at the beginning. Okay, so it's 0.
Okay, 0.
Yeah. So 0 meter per second. Initially, vertical velocity is 0 meter per second. What we are given? We are given the S that is equals to negative 125 meter. Do you agree?
Yeah.
Why negative?
Okay.
From here to here.
Yeah.
What is the level that it has covered? Vertically, it has gone to this level only.
Yeah, yeah.
Okay. So, and it is the downward vector. So you have to consider negative. You're getting it?
Yeah.
Okay.
Yeah,
so that's why negative 125 meter. A is equals to negative 10 meter per second square.
Yes.
And then we have to get the time.
Yeah.
We have to calculate the time. So how to do that? Which formula to be used?
We need T and we don't want to have V. Okay, so number 2, S is equal to UT plus 1/2 AT squared.
Yes.
So S is equal minus 125 is equal to 1/2 of minus 5 into the time squared.
Yeah, so we get T is equals to 5 seconds.
125 divided by 5, which is 25. T squared is equal to 25. T is equal to 5 seconds.
So we got the time taken over here.
Yeah.
Got it, right? Yeah?
Yeah.
All right. So now, so basically we got the time taken over here to be 5 seconds. So this part is done. The horizontal range. So let's talk about the horizontal range. That's the next part. Horizontal range, which formula to be used?
Okay, the horizontal range we use r is equal to velocity cosine theta multiplied by the time. So the velocity vertically we know is
Why? What?
horizontally the velocity is 20 meters. So
Yeah.
multiply by 5 we get 100
Allah.
cosine of
Why cosine?
and
Wait,
the
wait. Why cosine? See, there is no angle only. So theta is 0, right?
yeah, and theta is cosine 0 is 1,
This
right?
is 1. Yeah. Okay. So,
So we
so
get
if it
100
is,
meters.
yeah, exactly. So we got that. You got it, right? Then the
Yeah.
next thing is Vy, determining Vy. So how to determine Vy over here? So again, that is the vertical dimension. Vy is the vertical dimension, isn't it?
Yeah.
So we'll be considering the vertical motion. So vertically, what is the initial speed?
Uh, Initially 0.
Perfect. Final speed is Vy that we want to find out. But
Yeah,
for
we want
that,
to
what
find
we are
that.
given? A is equals to negative 10. We are given
Minus 10 and displacement is minus 125.
perfect. Which formula to be
T
used?
is 5 seconds.
All right, t is equals to 5 seconds. Yeah,
Uh,
which formula to be used?
the formula we need to have V and we can use any formula, but I think V is
Is
equal
equals
to
to
U
u.
plus
Yes,
AT is convenient.
perfect.
Yeah, it's the
Yes,
most easy
yes.
because the U is 0, so it's just V is equal to minus 10 times 5.
Yeah, minus 10 times 5, that is equals to minus 50
Minus 50 because it is
meters.
going down.
Perfect. That's why we are getting the negative answer. Okay, so
Yeah.
even Vy is done. Now, how to get V? For V, see, for V, we are having the horizontal that is 20 and the
Yeah,
vertical that
it's the
is
same, and the vertical, which is the
negative 50. So what we can do,
yeah.
20 square plus negative 50 square. Okay, you got it.
Okay.
Do you understand
Which
this?
formula are we using?
Pythagoras.
Oh, Pythagoras. Okay. Oh yeah. I see. I see.
Yeah. So then this is 400 plus
400,
2500. So that is
2,900 square root of 2,900, which gives
hmm,
53.8.
how much? 53.8, right?
Yeah.
All right. Now we have to get theta. How to get theta? Like if you are given the components that is 20
Yeah.
and this is negative 50. So
Yeah.
can you get theta? How to get theta? It is always
Let's.
tan inverse of vertical over horizontal.
Okay.
Okay.
Right. That's important.
Yeah. So what do we get? So tan inverse. You have taken HL, right?
Yeah.
Yeah. So you are supposed to know all these things. So tan inverse Vy is
Minus
50
50 over
minus
20.
50 over 20. What do we get? Get it in degrees.
One moment. So tan negative of minus 50 divided by 20
Tan
is
inverse of
minus
minus 50.
68.2.
Minus 68.2 degree. That means
Yeah.
downward it is minus 68.2 degree. So just the
Yeah.
magnitude, if you talk about just the magnitude, it is 68.2 degree. You got it, right?
Yeah.
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 All right. So I hope like you understood each and every part of this question.
Yeah, I did understand it. It's a bit actually difficult to get the head around because it's quite big with different steps. But once you split it into find this, find this, find this, I can quite easily understand, okay, what you have to do to get what.
Yeah. Yeah. So see, the thing is, keep in mind that like you need to follow the vector rules. Okay. You need to follow those formulae. You don't have to mix the horizontal and the vertical. Keep them separate. Okay. And use right sign convention. Okay. Because you're dealing with the vectors. Okay. Like
Correct.
here
Yeah.
in this one also, when you are, you can take the help of the first question which we did in the very beginning. Okay, so
Correct. Yeah.
over there we calculated this height. This height was coming out to be 93.75. You're getting it?
Yeah.
So this
Yeah.
maximum height will be 125 plus 93.75. So first question is anyway solved.
Correct.
Okay. Now so then after that you need to do the time of flight. Time of flight, use proper vector notation and right sign convention. Okay, and then decide which formula to be taken. So over here at this particular point, let's say point A, you are given the vertical speed. You will be resolving this 50 meter per second into horizontal and the vertical. So you know the vertical speed, so that will be the initial vertical velocity. Okay, and then to reach here, you're basically going downward. Vertically, you are going downward minus 125 meters. So you need to consider that as the displacement. You're getting, right?
I see.
Yeah. So for the time of flight, I'm saying. And then you will be considering A is equals to negative 10 meter per second square. So you'll be able to get the time of flight with the good use of formula. Horizontal range, you know you determine the time of flight and you know the horizontal distance, horizontal speed. So with that, you'll be able to calculate the horizontal range as well, right?
Yeah.
Okay. Then the method that we used just in this question, in the half projectile, for calculating Vy, V, and theta. Okay, over here. So using that same method, you can determine this Vy, V, and theta over here also. That is the fourth question. Okay?
Yeah.
So you can do this, right?
Yeah.
Do you have any doubt, any question over here?
No, not now, no.